section, we will discuss another eviction policy which is based on the frequency. This is known as least frequently used. If you remember the earlier sections which were based on the access time, least recently used and most recently used, then in the same way we can also implement another policy like most frequently used. Idea here is that the eviction is based on the frequency. So in this case, instead of maintaining the access time, we maintain some sort of frequency counter. Every time when we access an item from the cache, we update the frequency. By maintaining the frequency, we always know which element is the most frequently used. And similarly, we have the knowledge of the least frequently used item. Now, depending on the eviction policy that we are implementing, if the cache is full and we have to add a new element, then we can either evict the item which is the least frequently used or the most frequently used. Let's take an example of the cache where we are storing the results of a database query. So whenever we run a particular database query for the first time, we add that query to the cache with the results. And later, if we access the same query, it will be a cache hit. So we return the results from the cache. In addition to this, we also increment the frequency for that query. So after time t, the cache will have a number of queries with their corresponding results. And the query that has the highest frequency is a hot query because we are accessing or running that query very frequently. That means if the cache is full and we have to add a new query result to this cache, we can safely evict the item or the entry which has the least frequency in the cache. So by implementing the LFU policy, we will evict the query result which has the least frequency and we will add a new item to this cache. Talking about this scenario, this kind of eviction policy is effective for scenarios where the frequency of access is directly proportional to the usefulness of that entry. So rather than monitoring the recency or the access time, whether the element is the least recently used or the most recently used, it's the frequency that defines the usefulness of the entry. In those scenarios, we can use frequency-based eviction policies. Let's understand the policy with the help of an example. We will take the same example where we have an empty cache, and this cache can support at most 3 elements. That means the maximum size of this cache is 3. At time t, this cache is empty and we have to add a new item. The cache is empty. This is a cache miss. So we decide to add the item to the cache. This is the item number 1, which is added to the cache. Now, instead of maintaining the access time, we define the frequency. We increment the frequency. So let's say by default, we initialize the frequency as 1. All right. Now comes the second item. The cache has empty slots, so we can add the second item to this cache. This is item number 2, and it also has the default frequency 1. Then comes the third item, and we will add this third item to the cache with the frequency 1. Now let's say after time t, the application accesses the item number 1, which is a cache hit because the item is there in the cache. In that case, we will return the item number 1 from the cache, but we will also increase the frequency, which was 1, but now it's 2. And similarly, let's say after time t1, application accesses item number 3. This is the one. So in that case, its frequency will also be updated to 2. Now we have 3 elements in the cache. 2 of them have frequency 2, and item number 2 has its frequency counter 1. So if we have to add a new entry like this, but the cache is full, now we have to evict an element. So based on the LFU policy, we will remove the item number 2 because it has the least frequency as compared to item number 1 and item number 3. So that's how we determine which item has the least frequency. So we will evict the item number 2 and we will add this new item to the cache with the default frequency as 1. All right.